Welcome. In this section, we're going to start using gameplay tags. Gameplay tags are essential in GAS. We use Welcome. In this section, we're going to start using gameplay tags. Gameplay tags are essential in GAS, though they do exist outside of GAS and can be used in non-GAS projects too. But in GAS, we use them extensively. So what are they? Gameplay tags are basically names. They have the type F gameplay tag, and they're registered with the gameplay tag manager. Gameplay tags are hierarchical in nature. They take the form of parent, child, grandchild, where each level of the hierarchy is separated by a dot. They don't have to have a 3-level hierarchy like this example. They can have more or less. So why are gameplay tags so great? Can't we just use an F string or F name, or maybe an enum, or just booleans in some cases? Well, tags come with a number of inherent qualities that make them versatile. Yes, they seem a lot like strings or F names, and in fact, they are F names at the core. They have a member variable called tag name, which is indeed an F name. But their hierarchical nature makes them useful tools when it comes to making our code more flexible. Two tags can be compared for exact equality or even partial equality. Maybe they share the same root tag names only, and that might be significant in code. The gameplay ability system is designed to use gameplay tags in just about every single class in the API. We have the concept of giving tags to actors. What we mean by that is that we're giving the tag to an actor's ability system component. We then say that that ability system component has that tag. The ability system component implements an interface called the gameplay tag asset interface. This interface has a number of functions that make it easy to look at all owned tags, see if a particular tag is owned, or get all tags that match a given tag, or even see if any of the owned tags match a specified tag. Since these are interface functions, any class can implement this interface and decide how to handle these operations, although the ability system component handles these in its own way. Since classes can have multiple gameplay tags, we naturally need to store them in some sort of container. Now, we don't use T-arrays to store our gameplay tags. Instead, we use the gameplay tag container, which has some gameplay tag specific functionality and some added efficiency. Gameplay tag containers have the concept of a tag map count, meaning you can have more than one instance of a single tag in the container. It's this tag map count that tells us how many of a given tag exists in the container, and at times this could be 0, depending on whether a tag has been added and then subsequently removed, for example. So in debug mode, for example, we might see a given tag in the container even though its tag map count is 0. So that's something to be aware of. But all of these functions that check to see if a given object has a tag in its tag container are equipped to handle that situation. So it's the tag map count that they check for a given tag. Various classes in GAS can have and use gameplay tags. Gameplay effects, for example, can contain tags that they grant to the ability system component they're being applied to. Say we have an actor that applies a gameplay effect to a given ability system component. For this example, we'll say that this is a duration-based effect. Now, this gameplay effect can have a certain tag that it grants to the ability system component upon application. Now that ability system component has that tag. When the effect's duration expires and it removes itself, it removes the tag as well. Gameplay effects are designed to handle that. Now, in GAS, this is actually quite significant. Many operations depend on tags. For example, an ability system component might have some gameplay ability. Now, yes, we haven't learned about abilities yet, but let's just say that it has an ability that it wants to apply. Now, this gameplay ability may have a blocked tag, meaning that if the ability system component has that tag and attempts to activate the ability, it will not be able to do so. It's blocked because it has the blocked tag. Or an ability system component may have an ability which contains a list of required tags. In other words, the ability system component must have these tags to activate the ability. And if it attempts to activate the ability, it will not be able to do so, as it doesn't meet those tag requirements. It must have those tags to activate the ability. These are just a couple of examples of built-in capabilities that work with tags, but tags can be used for other things. We can use them to identify inputs, abilities, attributes, damage types, buffs and debuffs, messages, any type of data, or really anything else we can think of. So we'll be making extensive use of gameplay tags all throughout this course, and we'll first begin by learning how to add them to our project. So we'll do that next. I'll see you soon. Welcome back. So we know that there are these things called gameplay tags and that they're supposedly really useful. But how do we make them? How do we create gameplay tags? Well, gameplay tags are project-wide. As I mentioned, they're registered with the gameplay tag manager. And to create them, we have several options. And we're going to go over how to create them in the editor in this video. And to do that, we go to project settings. So edit and project settings. Under project, there's a gameplay tags section. And we have the option to make gameplay tags or add them to our project here. Now, by default, there's already a gameplay queue gameplay tag, and that's reserved for gameplay queues. We also see tests with generic tag here. But aside from those, we have no gameplay tags. Now, as you can see, we have add new gameplay tag and add new tag source. If we expand add new tag source, you'll see that we can specify a .ini, which seems to suggest that gameplay tags are associated with inis. And ini is a config file, and here's a config path. So as you can see, there's config/tag specified as a config path So that's one way to add them. Another is to simply expand add new gameplay tag. And this is how we can add them here in the editor. So we can add a gameplay tag by specifying the name, and we can optionally add a comment for the tag. And you'll see that under source, there's default gameplay tags.ini. And because we haven't used this add new tag source, well, that's the only option we have. That's the default option. Now, we'd like to add a tag. And tags are used to represent any number of things, including our attributes. So I'd like to create a gameplay tag for our health attribute. Now, I've made the decision to call my health attribute a vital attribute. That's kind of a project convention that I'm creating. And I'd like to keep every single tag that I make under a hierarchical, organized structure. So if I'm going to make a tag to represent my health attribute, I'm going to organize it in a hierarchy such as attributes.vital.health. And that way I can have other gameplay tags for other attributes that I may wish to categorize differently, which is what I will be doing throughout this project. Vital attributes will be things like health and mana, which are kind of tied to the life of the character, if you want to think of it that way. But later we're going to have other types of attributes, such as primary attributes, things that an RPG game would use like strength, intelligence, things like that. Those will get a different subcategory in the hierarchy. So for now, I'm going to make a new attribute called health, and it's going to be attributes.vital.health. And if we want, we can put a comment here and say, amount of damage a player can take before death. And I hit enter, and now the text boxes are blank. But down here, we see an attributes with a dropdown, and I can expand it. And there's vital, there's a dropdown here, and there's health. So now we've created this hierarchy, and we have one gameplay tag called health. Now take a look at this. We see add subtag, right? We can add a subtag by clicking on plus, and that automatically populates name with attributes.vital.health. And it's expecting me to name that subtag. I'm not going to use that. I'm going to delete that, but we can add another subtag to vital by clicking add subtag, and we can create a tag for the mana, for example. So I'm going to type mana, enter, and now expanding the dropdowns, here's health and mana. So this is a shorthand for typing out all those things. It kind of helps by filling in part of it for us. So we can have health, mana, we can do the max version. So next to vital, I can click add subtag and add a max health tag. I can do the same thing for max mana. So let's click the plus and add max mana. And this is how we add gameplay tags from here in the editor using this menu. Now, we know that tags are defined in an INI somewhere. So why don't we take a look at that? Because what this menu is doing is just making it easy for us to make the tags, but they really exist in a config file. Let's take a look at our config folder. And here's that default gameplay tags.ini. Now I'm going to go ahead and open it. I'll just open it with Notepad. Here it is. And here in default tags.ini, take a look at this. We have health, and we have mana, max health, and max mana. And check it out. This is how you really add tags, is you add them to this .ini. Now, of course, you can have other .ini files as well. As we've seen, we can add a tag source. But this is where our tags can go. Now, you don't have to add a new tag source for each subcategory of tags or anything. You can keep them all in the same .ini. That's totally fine. It's only if you're really concerned about organizing into sub-config files that you want to do this kind of thing. But you can also come in here and edit this directly. For example, mana. We can say a resource used to cast spells. And Control S to save and close that out. And we can come back into our project settings and hover over mana. And we're not going to see anything, but we can close out of the editor and we can launch the editor again. And back into project settings, into gameplay tags, we can hover over mana, and now we see in the pop-up that little comment there. So the comment is not really functional, but it serves as a way to kind of see what an attribute is supposed to do. So that's how we add attributes from within the editor. And it's a perfectly fine way to do it. They now exist in the INI file, which is great. Now, it's not the only way, and in the next video, we're going to learn another way. So great job, and I'll see you in the next video. Under Project, there's a Gameplay Tags section, and we have the option to make gameplay tags or add them to our project here. And that's reserved for gameplay cues. New gameplay verse to suggest and fig pat as a to simply add a comment tags.ini. Project settings pretty easily. We also saw that these exist in our config folder in one of our INI files, and we could even make new INI files to be gameplay tag sources. Now, this isn't the only way to make gameplay tags. There are a few others. One of those others is by making a data table. Let's see how that works. I'm going to go into my Blueprints folder, and I'd like to make a new folder in Blueprints for all things Ability System. So I'm going to make an Ability System folder. And here in Ability System, I'd like a new folder for game. Gameplay tags. So I'll make a gameplay tags folder, and here is where I'd like to put any data tables that we'll use to create gameplay tags. So here's how it works. We make a new data table. We right-click, go to miscellaneous, and select data table. Now, whenever you make a data table, you need to pick the row structure so the data table knows what fields are in a given row. Now, the one we're interested for gameplay tags is this one, gameplay tag table row. Select that, click OK, and we have a data table. I'm going to prefix it with DT for data table, and this is going to be for my primary attributes. So we have our, for other attributes, example, I'm going to make their gameplay tags now. So open it up. Now it's empty, but we can add a new row by clicking plus add, and now we have a new row, and the gameplay tag table row has a name, and it has its own tag with a comment. Remember, tags can have a comment associated with them. And again, these comments are not functional. They don't do anything, but they're kind of like code comments in C++. Code comments don't do anything either. They just serve to tell you something. So really, the only thing we have to do in this data table is change what this text box says for the tag. We don't have to change the name or anything like that. All we do is put what we want the tag to be. Now, this is error prone because you can make typos, so we have to be careful when typing in here. The tag I'd like to make is attributes.primary.strength. And for the strength, I'm going to add just a dev comment. It doesn't do anything. I'm going to say increases physical damage. Now, we haven't created any new gameplay tags yet. We have to make the table first, and then there's an additional step for this table to be converted into gameplay tags. For now, we're just going to make a couple more in the table before we actually make the tags. So I'm going to click plus add, and for the next one, I'll call this one attributes.primary.intelligence. Being careful not to make typos. And for intelligence, I'm going to add a dev comment, increases magical damage. Let's add another one. And for this one, I'm going to call this brilliance. Armor, one more, Mary, and we'll say, we'll save, made any gameplay, roast with the data, it's right there under data. Okay, so settings, and here under list, array of data tables, appropriate for the row, attributes, look at that, we have primary, and we can open that, and we have intelligence, resilience, strength, and vigor. It puts them in alphabetical order. Look at that. Okay, so that's how we can add gameplay tags with data tables. Pretty sweet. And this is one of my preferred ways to do it. I really like doing it this way because we now have a data table that we can go in and change, and it's just really convenient to do it this way. I personally like it. But that's just one option of many that we have in Unreal Engine. Okay, so now we know a couple of ways to make gameplay tags, and now these exist in our project. They're project-wide. So great job, and I'll see you in the next video. Welcome back. So now that we know about gameplay tags and how to add them to our project, and we have a few here, let's see how we can add gameplay tags to any given ability system component. We can do this in a number of ways. One of those ways is gameplay effects. Now let's see what happens if we take one of our crystals. Here's a health crystal. I'm going to duplicate one of them and bring it over next to my player start. Okay, so we know that we can pick one up, and for 1 second, our health starts to increase. One up, and for for 1 second, our health. We know that we can pick one up. Up, and for 1 second, our health starts to increase. And that's thanks to our gameplay effect in that crystal, which is in Blueprints, Actor, Crystal. And the health crystal uses GE Crystal Heal. Now, this is a periodic gameplay effect. Now, gameplay effects can have tags. And under the tags section, we have a lot of different types of tags, and they all do different things. This makes the gameplay effect extremely versatile, but also maybe a little bit confusing as you don't really know which tags to use and when. So we'll quickly go over all the different types of tags, and then then we'll add a tag to Crystal Heal and see how we can add that to Aura's ability system component. So let's go in order from top to bottom. First, we have gameplay effect asset tag. And if we expand that, we have combined tags added and removed. Now, if we hover over these, we get useful comments. This one says the gameplay effects tags the gameplay effect has and does not give to the actor. Okay, so that's good to know. If we put some tags here, when the gameplay effect gets applied, it's not going to give those tags to the actor's ability system component. It just has the tags. So why is that useful? Well, we're going to see very shortly why that is useful. Now, why are there three types: combined, added, or removed? Well, hovering over combined says tags that I inherited and tags that I added minus tags that I removed. This is what we'll see in all tag containers, and that's what these are, is gameplay tag containers that exist in all the engine classes. Now, it doesn't make a whole lot of sense here in a gameplay effects because we don't typically subclass gameplay effects. So we don't create inheritance hierarchies of gameplay effects, but we do sometimes make inheritance hierarchies of other GAS classes. So we'll see this trend. Now, added is, the comment says, tags that I have in addition to my parents' tags. So a class will inherit its parents' tags, but it can add its own. So in other words, if we want to add a tag to this container, we would add it here. Now, removed says tags that should be removed if my parent had them. So again, we won't be creating a child from any gameplay effect, but if we do sometimes make inheritance hierarchies of other GAS classes. So we'll see this trend. Now, added is, the comment says, tags that I have in addition to my parents' tags. So a class will inherit its parents' tags, but it can add its own. So in other words, if we want to add a tag to this container, we would add it here. Now, removed says tags that should be removed if my parent had them. So again, we won't be creating a child from any gameplay effect, but if we did, if this were a child, for example, it would inherit its parents' gameplay tags. And if we wanted this child to not have one of those inherited tags, we would add that to the removed section here. Now, we know that adding a tag to gameplay effect asset tag doesn't give that tag to the actor that's being hit by this effect, right? So let's continue down to the next one, which is granted tags. And if we expand it, we see the same thing, combined, added, and removed here. Now, hovering over granted, we see these tags are applied to the actor I am applied to. Okay, so that means if we put a tag in here, it will be applied. It will be given to whatever we hit with this effect. So let's see how that works. Let's add one. And we add one with the added, right? So we can click on the dropdown and let's just add attributes, vital, health. We'll add that. And you'll see that as we click on the checkbox for health, we can add the tag and it appears here. Now to remove it, we just hit the red X. So adding and removing is pretty simple. Now because tags are hierarchical, we wanted to do that, but we're going to add attributes, vital, health. Let's add that. Now we can add multiple, right? We can expand the dropdown and check multiple checkboxes. And as we add them, we'll see them here. And of course, we can hit the X here to remove them. It's the same thing. And also the granted tags. Now we see that all of the tags we added to the added section are now in combined tags. And if the parent class of this had some tags in its granted tags, we'd see those here too, but it doesn't, so we don't. But because we added one to the added section, it's now in combined tags, and we see that as soon as we compile. If we remove it from added and then compile again, it goes away. It's no longer in combined tags. So anyway, let's put that health tag back into the added section. We can compile, and let's see what happens. I'm going to press play and show debug ability system, and keep your eye right up here on owned tags, and let's pick up the crystal. And there it is, attributes, vital, health. It was only there for a second. Pick up the crystal. I right up show debug, and let's see what happens. I'm going to press play and show debug ability system, and keep your eye right up here on owned tags, and let's pick up the crystal. And there it is, attributes vital health. It was only there for a second. Because it gets removed as soon as this gameplay effect expires. To make this a little easier to see, let's change the duration magnitude. Here's the duration magnitude. It's set to a second. Let's set it to 4 seconds. That's a little easier. And then we can press play, show debug, and pick up the crystal, keeping our eye on owned tags. And there it is, attributes vital health. And notice in parentheses it has a 1 there. We can keep count of these. Now, that's because tags can be stacked, much like gameplay effects can be stacked. But there's a key difference here. Our GE Crystal Health has its stacking type set to aggregate by target with a stack limit count of 1. Okay, so we can only stack 1. But let's say we increase that. Let's say we want to be able to stack 4 at a time. You might expect that we would stack those gameplay tags that are granted. In other words, this attributes vital health tag, you would expect us to add that tag 4 times and we'd get 4 stacks. But that's not how it works. You see, if we're applying GE Crystal Health and it's stackable, in this case it is, we're only going to get that tag once because it counts as just a single application of the gameplay effect, only it has stacks, right? And based on the stacking policy and all of these parameters, the meaning of that depends on all these settings. So if I duplicate a few of these, let's have, say, 3 of them here, and press play, and show debug, and pick them all up, we still just have a single health tag until they're all gone, and then it's gone. So with a stackable effect, we just get that tag once because it's the effect that stacks. It's the effect stack count that goes up when we get multiples. However, let's say that this is not a stackable effect. If we take our stacking type and set it to none, now it doesn't stack anymore. We just apply the effect multiple times, and each time counts as a new gameplay effect. Let's see what happens now. We'll show debug and pick up all 3 of these, keeping our eye on the owned tags. And now we see that we have 3 of the attributes of vital health tags, and then it went down to 2, and then down to we of these, keeping, let's see what multiple times, and each time counts as a new gameplay effect. Let's see what happens now. We'll show debug and pick up all 3 of these, keeping our eye on the owned tags. And now we see that we have 3 of the attributes of vital health tags, and then it went down to 2 and then down to 1 when those effects expired. So that's a key difference between stacked effects and stacked tags. If our effect doesn't stack, then we'll get multiple effects applied, each of which adds that tag to the ability system component. And when the same tag gets added twice, then the tag count goes up. But if this is a stackable effect, if we set its stacking type to anything other than none, then applying this effect multiple times means that anything other than none, then applying this effect multiple times means that the effect stack goes up, and we're only going to apply that tag once. Make sense? Okay, so now we know we can add a tag when a duration-based effect is added. So that's nice. And there are ways to respond to when a tag gets added to an ability system component, so that can be useful. What happens, though, if we add a tag to, say, an instant gameplay effect? We know that these potions have instant gameplay effects. Let's go back into our potion folder, into GE Potion Mana. And let's go to our granted tags, and let's add a tag. Let's add the mana tag to it. Let's see what happens. Granted that these potions have GE, add the mana tag to it. Let's see what happens if we pick up one of the potions. I'm going to show debug, keeping my eye on the own tags. I'm going to pick up a potion. Wait a minute, there's nothing there. So we don't see anything. So that tells us something, right? Granted tags really only mean something when our effect has a duration. Because when the effect is gone, the tag is removed. And if it's an instant effect, well, there's no period during which we have the tag. We don't get it. So it doesn't matter in an instant gameplay effect. So I'm just going to clear that. Doesn't matter. But what happens if we want to receive a tag anyway? What happens if we pick up a potion and we want to know, based on some gameplay tag, that we just picked up a potion and we want to show something to the screen? We want to display a message that says, picked up health potion. Well, that's where our gameplay effect asset tag container comes in, because we have ways to know when any type of effect has been applied. The ability system component has lots of ways to know. We're going to learn about those ways to know. In fact, we're going to peek at a couple of them in the code base now, and then in the videos to come, we'll make use of them. So I'm going to undo what we did by removing that tag from Crystal Heal. We don't want to use granted tags. So removing that tag and closing those gameplay effects. I don't need project settings. I'm going to close that as well. Make sure everything is saved here. I'm going to close out of the editor. And I'd like to take a look at the ability system component class. Now, here in Writer, I can hit Shift and search for ability system component. Here's the header file. And it can actually be really informative to just go through this class, right? It's a big class. There are almost 2,000 lines of code, but it's an informative class. It's filled with comments everywhere. This is basically your documentation for GAS, is the code itself. It's filled with comments. This is basically Epic's documentation for GAS. And if you're not pressed for time, I recommend just sitting down and reading through ability system component.h. Read all the comments, read everything, because it's all going to make sense. And you'll also see the things that the ability system component has. So while you don't have to, it might sound like torture to you to read 2,000 lines of code, but I do recommend it. I recommend just sitting through, even just skimming through. You don't have to look at all the code. Just look at the comments and the names of the functions are going to make sense. And go through this class, right? It's a big class. There are almost two, and search for ability system component. Here's the header file. And it can actually be really informative to just go go through this class, right? It's a big class. There are almost 2,000 lines of code, but it's an informative class. It's filled with comments everywhere. This is basically your documentation for Gas, is the code itself. It's filled with comments. This is basically Epic's documentation for Gas. And if you're not pressed for time, I recommend just sitting down and reading through Ability System Component.h. Read all the comments, read everything, because it's all going to make sense. And you'll also see the things that the Ability System Component has. So while you don't have to, it might sound like torture to you to read 2,000 lines of code, but I do recommend it. I recommend just sitting through, even just skimming through. You don't have to look at all the code. Just look at the comments and the names of the functions and variables. That's it. Just skim through the comment, take note of what the function is called, and move on. Skim through the comment. And the functions without comments, just take note that they're there, right? This is going to let you know just what the Ability System Component class has in it. So that way, in the future, if you want to do something, you can just think, well, I did see something back when I skimmed through it related to this. Maybe that'll work, right? So anyways, that's just a piece of advice that I have for you. Now, after you've done that, I want you to search for So anyways, that's just a piece of advice that I have for you. Now, after you've done that, I want you to search for on gameplay effect applied, and look at this. Here's a declare multicast delegate 3 params called f on gameplay effect applied delegate. If we keep searching for the same thing, we'll see that here's a function on gameplay effect applied to target, applied to self. And if we scroll just a bit past that, here we see some actual delegate variables. Now, the comments are pretty useful here. On gameplay effect applied delegate to self has a comment that says, called on server whenever a GE is applied to self. This includes instant and duration-based GEs, or gameplay effects. Now, called on server, that's pretty significant. And based on our replication policy, we should know whether or not gameplay effects will be replicated. In fact, let's pull up that table real quick. Here we go. It's good to go back and look at these things because this table real quick. Here we go. It's good to go back and look at these things because this actually has more meaning for us now, doesn't it? Now that we're starting to get into gameplay effects. Now, we're not using full for anything. We're using mixed and minimal. Aura uses mixed and the enemies use minimal. Now, we see that in mixed, gameplay effects are replicated to the owning client only, gameplay cues and gameplay tags replicated to all clients, and for minimal, gameplay effects are not replicated. Gameplay cues and gameplay tags are. Okay, so that's good to know, isn't it? And here we have a delegate that will be broadcast whenever any gameplay effect is applied to self. That means to this ability system component. We also have on gameplay effect applied delegate to target. So when a gameplay effect is applied to someone else, this includes instant and duration-based GEs. And when it says duration-based, it's counting both duration and infinite. Now, next we have on active gameplay effect added delegate to self. Now, this is gameplay effect added, right? Not just applied, but added. Whenever you see added, that means it's for duration-based gameplay effects. And here it says instant gameplay effects did not trigger this. So this is only for duration or infinite. Here we have on periodic gameplay effect execute delegate on self, and it says called on server whenever a periodic gameplay effect executes on self. So say we have a periodic one, right? Every second something is modified. Well, here's a delegate that will be broadcast on the periodic execution. And then here we have one for when a periodic GE is executing on a target. So in other words, we have a lot of different things that we can take advantage of here, right? And I like on gameplay effect applied because it includes instant and duration-based gameplay effects. And of course, we can do things when effects are removed as well. Let's search for on gameplay effect removed. And we have a lot of things. Let's keep searching. Let's search for on any gameplay effect removed. And here's something that's called when any gameplay effects are removed. Now, this is a function, but it returns the delegate. It returns a reference to it. So we'd have to call this function if we want to bind anything to this delegate. And these delegates broadcast info, right? We're going to be able to know what effect is being applied, added, removed, whatever we want. The ability system component has you covered, okay? So in the videos to come, we're going to bind some stuff to these delegates so we can know. And then we can get those delegates and perhaps see what tags they have. And that will allow us to retrieve tags for a gameplay effect that's perhaps instant, right? And then we don't have to rely on duration-based effects if we want to do something in response to a gameplay effect applied to us, like showing something in the HUD. So excellent job. I hope you at least skim through the ability system component. If you're super curious, you can go to the CPP file and see the implementation details of it as well. So do that if you're so inclined, and I'll see you in the next video. Welcome back. So now that we know that our ability system component has some inherited delegates, let's see what happens when we bind to one of these and apply a gameplay effect. Now I'm interested in on gameplay effect applied delegate to self. This seems like a pretty nice one. And we need to know what the function signature should be for a callback that can be bound to this. So I'm just going to right click on its type, go to declaration or usages, and here it is, delegate for when an effect is applied. And we see that it takes an ability system component pointer, a gameplay effect spec, and an active gameplay effect handle. So in other words, when the ability system component broadcasts this delegate, it's going to pass this information in, and we'll be able to receive that, which is actually pretty nice. Now, if you've seen a declare multicast delegate signature, you might have seen sometimes that these macros have the parameter names, but in declare multicast delegate, you can just have the types without the names there. That's totally fine, and that's why we have this here. So we know that our callback needs to have these three input parameters, needs this signature. So let's make a callback for our ability system component that we can bind to the delegate. So I think what I'm going to do is right click on ability system component.h and close the other tabs for now, and open my public folder, ability system, and get my Aura ability system component.h. And look at that, so far it's clean. So we're going to add our first function to it. And I'd like to make this function protected. So I'll make a protected section. And the function is going to be void, and it's going to be, let's just call it effect applied. And we know that it needs to have this signature. If we go back to ability system component, it needs to have these three inputs. So I'm going to copy them and I'll paste them here. Now, funny thing is, those parameter names are actually optional here too. So, bet you didn't know that. But I prefer to give them names here so they're descriptive. So I'm at least going to give them a name. I'll call it ability system component for that one. For the gameplay effect spec, we'll call it effect spec. For the active gameplay effect handle, we'll call this active effect handle. And and we can generate a definition. So now we have a callback, but we want to bind this to that delegate. Back in ability system component, we want to bind it to this one, the delegate of this type. I'm going to copy it, Control F to find it, and here it is. On gameplay effect, applied delegate. To self. I want to bind to this. Where can I bind to it? Well, we typically like to do this when the actual game starts, and not really in constructors, as those are fired off quite early. So it'd be nice if we had some sort of spot to bind to this delegate early on. And really, a pretty easy way would be to make a function that we could call as soon as something happens, like we've initialized our ability actor info, for example. That's pretty early on. So we could call some function to let the ability system know, okay, it's time to go ahead and bind to your delegates. And we know that we have a function here in Aura character. We call it init ability actor info. We're calling that in Aura character when we want to call init ability actor info on the ability system itself. Well, we could make this a virtual function on Aura character base and just implement it in both Aura character and Aura enemy. And then whenever they call it, they can also call some function on the ability system to let it know it's time to bind to any delegates it wants to bind to. So I'm going to take this function, init ability actor info. I'm going to declare it in Aura character base and make it virtual. And it can be protected in Aura character base and make it virtual. And it can be protected. So I'm going to make a virtual
cứ cố gắng, vì chúng ta chỉ được sống một lần trong đời. Đừng vì một hai câu nói mà thay đổi bản thân mình. Thành công sẽ mỉm cười. Đó là thành quả thích đáng cho những ngày nỗ lực cho gia đình, người yêu thương bạn và cho chính bản thân bạn.
Void init ability actor info. And I can just give it a empty definition here. But then in Aura character, we're now going to be overriding it. So it's a virtual override. And in Aura, in init ability actor info, I'm going to open the CPP file. We can call some function on the ability system. I'm going to open it. And be here. And I can just give it ability to make a. I'm going to declare it in Aura character base and make it virtual. and it can be protected. So I'm going to make a virtual and it can be protected. So I'm going to make a virtual void init. So a character base. So I'm going to declare it in or a init ability delegates on the ability and just implement it. In both aura character and aura enemy, and then whenever they call it, they can also find to init ability X virtual info. And after we're now right, and file, we can call some function on the ability system component here, tell it to go ahead and start binding its delegates. So we'll get to that in a second. I'll keep that open, but I also want to override this in aura enemy, so aura enemy can do it as well. So in the protected section, I'm going to say virtual void init ability actor info override. And I'll generate the definition here. I don't care about the super call. So now Aura Enemy and Aura Character can implement this each in their own ways. Now Aura Enemy is just calling an ability actor info in its begin play right here. So now instead of calling it on the ability system component directly, I'm going to cut that line and put it right here in an ability actor info, and then just call this function here in begin play instead. But now we can do other things like call some function on the ability system component, which we still haven't made, so why don't we make one? So Aura ability system component here can get a public function. So let's give it a public section. And it'll be a void function, and let's just say ability actor info set. So when this function is called, we know that the ability actor info has. We can call this when we set the ability actor info. So we'll do that in Aura character in init ability actor info as soon as we call init ability actor info, which is right here. Now we're getting the ability system component from Aura player state, but we are going to need to cast it now. So we're going to say cast to u Aura ability system component. And by the way, writer is going to give me component. And by the way, writer is going to give me the Aura ability system component header file now. And we'll cast the Aura player state get ability system component. That's going to give us the ability system component we're casting now. And we know that Aura character should have an Aura ability system component. So we're going to take the result of this cast and call ability actor info set, since we've set that. Cool. Now we can do this on the enemy as well. So we have the ability system component. We're going to cast to u Aura ability system component. We're casting of the in this action, and it'll be a void function. And let's just say ability actor info set. So when this function is called, we know that the ability actor info has been set. So let's create a definition for it. And there, we can call this when we set the ability actor info. So we'll do that in Aura character in init ability actor info as soon as we call init ability actor info, which is right here. Now we're getting the ability system component from Aura player state, but we are going to need to cast it now. So we're going to say cast to u Aura ability system component. And by the way, writer is going to give me the Aura ability system component header file now. And we'll cast the Aura player state get ability system component. That's going to give us the ability system component we're casting now. And we know that Aura character should have an Aura ability system component. So we're going to take the result of this cast and call ability actor info set. Since we've set that. Cool. Now we can do this on the enemy as well. So we have the ability system component. We're going to cast to use Aura ability system component means the character is now dependent on the actor info set. Set. Now keep in mind that means the character is now dependent on the ability system component. And so we'll make sure that our ability system component doesn't have to know about the character. We'll keep the dependency one way in that sense. Okay, so now our Aura enemy and Aura character, as soon as they set their ability actor info, they'll call ability actor info set, which means the ability system component can now do things like bind to delegates. And that's what I'd like to do. So I'm going to go ahead and close Aura character. I'm done with it. I'm closing Aura enemy, Aura character base, and we're going to go into Aura ability system component, and we're going to bind our delegate. So let's recall what that delegate is called. It's this one, on gameplay effect applied. Delegate to self. Let's go ahead and paste that into our ability actor info set. And go ahead and paste that play effect apply delegate to self. Let's go ahead and paste that into our ability actor info set. And we're going to hit the dot, and we're going to bind to this delegate. Now, what kind of delegate is it? We can go ahead and go to its declaration. It's a multicast delegate, 3 params. It's not dynamic, so we can't use add dynamic. We have to use add uObject or any of the others, right? But we're going to add uObject, which means we're going to pass in this for the user object, and for the function, we'll pass in this function here. Don't forget the address of operator, and don't forget to make sure it's fully qualified with the class name. Now, we're binding this, right? Which means we have effect applied, a callback that will be called in response to really any effect that gets applied to this ability system component. So why don't we just test this out by, say, printing a debug message. So we'll say gengine add on screen debug message, which takes a key. We'll use 1. Time to display, let's say 8.f, so 8 seconds. F color, let's make it blue. For the string, we'll make an F string that says effect applied, and the rest of the inputs are optional. So that's all I want to do. And now I really, really want to test this out. So I'm going to run, but I'm going to run in debug mode. That way, we could place a breakpoint there and see what the values are for all these input parameters passed in. But first, let's get that debug message printed to the screen. Okay, so we're going to hit play, and we're going to pick up a health crystal, and there's our effect applied. And we can pick up multiple. Now, I probably should have not used key 1 because now all messages will replace older messages, but that's okay. Let's pick up a instant effect, or rather a pickup that applies an instant effect. We see that we still get effect applied. Excellent. Now, we're not really formatting a string that has any sort of information in it about the effect. I'm not going to bother with that. I'm going to instead place a breakpoint here. And that way we can inspect these variables to our heart's content. So now I'm going to press play, and let's pick up a health crystal. And we hit that breakpoint. Now, here at the breakpoint, let's let writer collect some data. And here we have our data. So our callback has the ability system component, and that's owned by BP or a player state. That's great. We also have the effect spec, which is down here. We can expand the dropdown. And the effect spec has all kinds of information. We know that it's GE Crystal Heal. We know basically anything we want to know about it, right? We have all that information. And of course, active effect handle. This is the active effect handle. We have that if we want it for whatever reason, right? Remember, we used this before to remove an effect in the past with our health crystal. So this is really, really nice. We have the ability to get information at runtime about an effect being applied. So